Good morning and welcome all to today's Adbri webinar. My name is Matt Holdstock and I'm a Seniorologist at the Australian Wine Research Institute. In today's session, we'll be hearing from the Bureau of Meteorology with the seasonal outlook for the 23-24 summer and also an update on some of the major agricultural projects that the Bureau are involved in. In the spirit of reconciliation, the Adbri acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea and community. We also pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Just also like to acknowledge Wine Australia for providing the funding and support for the webinar program via the Adbri Extension and Communication Project. Before we jump in and make a start, a couple of quick reminders to anyone who is new to the Adbri webinar program. If you'd like to provide a comment or ask a question throughout, please click on the Q&A button on the Zoom toolbar, type in your question and click it to send it through. We'll also hold a Q&A session at the end of this presentation, but feel free to send through questions at any stage throughout. A reminder also that this session is being recorded and the link will be sent to you later to view via the Adbri's YouTube channel. For anyone who's just joined, welcome today. Today's webinar topic is the seasonal outlook for the 23-24 summer and an update on major agricultural projects that the Bureau of Meteorology are involved with. And it is a great pleasure to welcome our first speaker today, Dr. Janatan Nahar. Janatan is an extended prediction specialist at the Bureau of Meteorology. Janatan is also a professional hydroclimatologist specialising in climate projection and has more than 15 years of experience in the climate and the hydrology sector. Janatan obtained her PhD from the University of New South Wales in Sydney, Australia, in climate modelling and drought projection. Janatan also has experience in water assessments, especially for the Murray-Darling Basin. So Janatan, if you're ready to make a start, I will hand the control over to you.
Thank you, Matt. I will start. Good morning or afternoon, everyone. My name is Janatan, as Matt mentioned, and I work for Australian Bureau of Meteorology as an extended climate prediction specialist. Bureau of Meteorology provides climate information through various products and services that includes observation, forecast, warnings, analysis, and advice. Today's focus is climate outlook for coming season, which is summer. But after the outlook, I will briefly touch climate change and the risk associated with that for Australia. So the presentation is mainly divided into three sections. I will start with the drivers of our climate, followed by recent conditions and seasonal outlooks and projected risk in changing climate. Before going to the climate forecast, I want to briefly mention the temporal spectrum for forecast and associated uncertainty. Ranging from minutes to century scale, Bureau of Meteorology issues forecasts which are used for various purposes from our day-to-day life to strategic planning and policy making. Broadly, we can categorize these into three. The first one is weather. Anything from minutes to weekly scale is known as weather domain, and these are used for emergency response and sectoral preparedness. The second one is climate variability, multi-weeks to seasonal scale, and that is known as outlook, like the one I am presenting today. So this provides guidance for strategic planning at national and state level. There is a lot of overlapping between the use of weather and climate forecast, but grossly it is like weather forecast guides us to what type of, say, clothing we should wear today, and climate forecast kind of guides us what kind of clothing we should buy for the season. The third scale is climate change scale that talks about decades to century level, and they are more known as model scenarios and used for international policy negotiation and strategic planning. Given that we have climate forecast for every time step, the biggest challenge is how we use them, and with the associated uncertainty. So from this plot, you can see that the longer is the lead time, bigger is the uncertainty. Therefore, it is understandable why our outlooks do not turn into reality all the time. So we should keep that in mind, the associated uncertainty with any forecast. When and how we can achieve more certainty in our forecast, I'm going to talk about that more a bit later. So, Australia's climate can vary greatly from one year to another, but most of these variations come from the drivers of our climate. There are many drivers that work at various time of the year and impacts local to continental weather. So, most important driver for Australian climate is El Nino Southern Oscillation, or ENSO, and it is a irregular periodic variation of wind and sea surface temperature over the tropical eastern Pacific Ocean. The warming phase of this surface temperature is known as El Nino, and the cooling phase is known as La Nina. So when ENSO is at La Nina state, it is associated with above average rainfall and below average temperature across much of the country. On the other hand, El Nino is associated with dry and warm condition. uh, Maps here showing the pattern of temperature and rainfall during a typical El Nino condition for summer. So the next question is where we are sitting in terms of ENSO at this moment. Considering the criteria meeting the threshold for El Nino, Bureau of Meteorology has officially declared El Nino on 26 September of this year. So much warmer and drier condition in coming months is expected. The bottom panel here is showing our model guidance for ENSO. All the models are indicating that El Nino even may last until end of March. After ENSO, the second most important climate driver is Indian Ocean dipole. So this is similar to ENSO but happens in Indian Ocean. So Indian Ocean dipole, or IOD, has two phases, positive and negative, which influence our climate. So where we are sitting at this moment in terms of IOD, let's look at the plot. So Bureau has declared that a positive IOD event is going on at this moment in Indian Ocean. And what does it mean for us? Positive IOD event suppresses rainfall over Australia. And if we look at our model guidance, it shows that this positive IOD event may continue to the beginning of summer. Now that we have two major drivers going on at the same time, let's look at how the combined influence of these two drivers affect us. So we know that El Nino means dry condition and IOD positive means also dry condition. So the combined effect is more drier condition and more warmer condition expected for rest of the season in general. So after El Nino and IOD, there's another driver which can be really significant at some time, which is called Southern Annular Mode, or SAM. So SAM, when it is negative in summer, increased chances of rain for much of Northeast, and at positive phase in summer, it increased chance of rain for much of the Northeast. So at this moment, the plot at the corner, top corner, is showing that SAM is slightly negative, but for the rest of the season, till December or end of December, it's seems like SAM will be mostly neutral. So we should expect less influence from SAM during this time. So this is the summary of our climate drivers at this moment. Beside ENSO, IOD, and SAM, we also have to consider Meridian Oscillation, or MJO, and the long-term change in our temperature and climate. So the other thing here, why we discuss so much about the drivers, why these drivers are important for us, because we don't actually need to look at the drivers for climate forecast separately. So drivers are included in our model to produce good forecast. But when one or two drivers are active, then we have better accuracy in our prediction, because drivers guide or can give us indication of in which direction the climate may go. So when there is no strong driver active, it is all noise or chaos, and more the weather is at more weather scale. So that's why drivers are important for prediction. So after the drivers, let's move on our recent condition. So this is the maps for August to October period, which is last 3 months. As we can see, in terms of temperature, winter was very warm, followed by the spring season. To date, it's almost end of spring season. And the maximum temperatures were highest on record across much of Western Australia and parts of New South Wales. Minimum temperatures were also much higher, especially in Western Australia. And in terms of rainfall, August to October was very dry, and some areas were driest on record, especially in the southeast Queensland area. So let's look at the cool season rainfall, because we know that for agriculture, cool season rainfall is very important, which is between April to October. And the cool season rainfall has been average with dry condition along the east and southwest. There are pockets of rainfall deficiencies already emerging, as we can see from the three plots on the right side. The last 3 months rainfall deficiency, last 6 and 11 months deficiency. As last 3 months were very dry, we can see the emergence of um, severe severe dryness in the southwest Queensland, and that's extended in the northern New South Wales and also in Northern Territory. And for 6 months, it's more prominent for southwest of Western Australia. So after 3 consecutive wet years, we have seen 3 consecutive La Nina and wet year, landscape started to dry, and the streams are having mostly average flows. So the top plot on the left is showing stream flow condition in October. Mostly it is average for many of the stream gauges. And the soil moisture, the root zone soil moisture, which is top 1 meter of soil, is showing that the drying tendency in the east and in southwest. And the other map on the right corner is showing the storage condition. So most of the storages are actually full, but that's the influence of last 3 wet years, and this will definitely reduce when the irrigation season starts. So now the outlook. So looking at the forecast for the coming month and season, first we look at December forecast. So in terms of maximum and minimum temperature and rainfall, I'm going to show. So first is chances of above median. So temperature, the chances of seeing above median temperatures are very high, both maximum and minimum temperature. For the rest of and in terms of rainfall, Northern Australia and West Coast have low chances of seeing median rainfall. That means dry condition expected. For the rest of the country, probability of seeing median rainfall is 50-50. Now, looking at unusual conditions, which is the bottom panel. So what we understand by unusual condition is the top and bottom 20% of historic range. So in terms of temperature, chances of unusual cold conditions are nil. There is no chance almost. But chances of unusual high temperature is highly likely for almost everywhere, especially for parts of Western Australia and Queensland. Chances of unusual high temperature are 2 to 3 times more likely than normal, as you can see from the color code. For rainfall, very high chance of seeing unusual dry condition along the northeast coast, but elsewhere it's not that prominent. So if we go to the similar forecast for the seasonal scale, that means for the next 3 months, the conditions are similar to the month of December in general. low chances of above median rainfall for northern Australia. Chances of unusual dry conditions are more likely for northern Queensland. But the most significant thing to consider for the season is the very high chance of seeing unusual warm conditions. Unusual warm daytime temperatures are 3 times more likely for larger part of the country. But unusual high night temperatures are almost 4 times more likely than normal. That makes the situation worse for heat wave condition. I will talk about that in heat wave slide. A bit more extended situation for January to March, but the scenario is not much different. So that means we will be seeing this warm and kind of dry condition for most of the season and a bit beyond the season, because this is still March. So now in terms of stream flow forecast, Bureau of Meteorology has a stream flow forecast service for next coming 3 months, which is November to January. Stream flows are expected to be mostly lower than normal, but that is quite expected because we expecting low rainfall and already dry condition existing. So stream flows will be below median. So now, what's the implication of this condition? So this is a map for Australia where we can see the fire danger season across the country, and that varies in time. So as we move in the north, the fire season starts early, and to the south, it's more later in the year, especially for the southern Australia, southwest of Western Australia. The fire season, the most dangerous fire season is December to February. That means the summer season and the season we are talking about now. So that's going to be a concern for this part of the country and also the other part. But the most significant is for that region. Summer bushfire outlook is actually yet to come from AFAC, and it will be available by the end of November. So please keep an eye on the website for that. But bushfire is particularly a concern as a result of reduced rainfall in the previous season, high fuel load from vegetative growth in last 3 years, and obviously from above average temperature. Now I will just quickly show a bit of wind outlook. So Bureau doesn't have any operational wind product at climate scale. This is coming out, these plots are coming out from our access model, which give an indication of the surface wind for coming months, which probably be important for wine growers. So I just thought like put these slides together. In general, low chances of seeing above median winds across the country, with some patches of high and average chances. 7-day wind forecast is actually available from our, which is weather scale from Met-I. If you go to the Bureau's website, I think Jamison will talk a little bit about that. So I am just showing it at climate scale. So next is heat wave. Again, Bureau doesn't have like heat wave things at climate scale, but as I said, like we are expecting very high temperature daytime and nighttime that will increase the possibility of heat wave. So bushfire and heat wave are the two biggest concern for this season, but this is also beyond the climate scale level. So Bureau has 3 days heat wave forecast service. So you can go to the site and check the heat wave forecast for next 3 days, and that extends up to 7 days. So heat wave is actually calculated based on excess heat factor, which is a combination of average temperature for 3 days period and compared with observed temperature for the location over past 30 days. So that's another thing that you can look for. I think the last thing, the most important summary for the high risk weather season is like it's a pictorial view of the hazards and risks related to climate and weather for coming season. As we can see, not all the hazards are active at this moment for everywhere, and not and they are really different across the country. say like as I said a couple of slides before, that fire danger is more prominent for southern part of the country, extreme heat almost everywhere, also marine heat wave, and we have, because of low rainfall and high temperature condition, drought and flash drought, like short term drought is possible, dust, thunderstorm, asthma, these are concerned. And then when we have El Nino situation, the chances of tropical cyclone is usually lower than average, so low chance of seeing tropical cyclones. But and severe thunderstorm doesn't have much impact on that, and we expect to see less concern about riverine flooding and coastal flooding because of the dry condition. I think that's that's all from the outlook side. Now I'm quickly going through the projected risk of our climate, and that's coming from changing climate. As the science is telling us that our climate has changed and more changes are likely. So what are we observing? So this timeline here shows the recent decade. We have experienced many record-breaking climate events ranging from drought, bushfire, heat wave to storm and flooding. So the question is, do we know everything about the future climate that we need to know? Do we know what will be our future climate extremes and where and when it will occur, how frequent, and what is the consequence? So those are the emerging questions. So for that, the Bureau of Meteorology and CSIRO play an important role in monitoring and observing our future, monitoring an observed and future climate in Australia, for Australia. And the outcome of that is presented in a report which is called State of the Climate. So this report is a synthesis of the science informing our understanding of Australia's climate. So the latest report released last year, which identified that Australia's climate has warmed by an average of 1.47 degrees since the record begins in, which is like 1910 or so. The report also finds Australia will continue to see an increase in the frequency and intensity of extreme events like heat wave, fire weather, and heavy rainfall. So let's look at some of those things. So we already know that Australia's climate has warmed since 1910. So the first plot here in the left is showing the time series of sea surface and air temperature anomalies for Australia. Anomaly is the deviation from long-term mean, as we know. And we can see that since 1970s, our temperature anomalies are constantly positive, means we are continuously observing above average temperature. And the bar plot on the right is showing the number of days in a year when temperatures were extreme. In the last 3 decades, the extreme temperature days are continuously increasing with that longest spike, which is 2019. And we all remember that. So this is the extreme temperature. And with that, there has been an increase in the number of days with high fire danger. The FFDI, which is an indicator of fire weather condition for a given location. So here this map is comparing FFDI for a period of 1950 to 86 and then 86 to 2022 period. So the value has changed significantly. As you can see, like in Southeast coastal Queensland, inland New South Wales, Victoria, and Kimberley region, if the number of dangerous fire weather days were 5 before, it is now 30. So that level of increase. And this is another example how our fire season is worsening, not only in terms of number of days above dangerous threshold of FFDI, the season is also starting earlier. So if you look at the plot on the right hand side, the season that used to start in 1970, sometimes in October, it is starting like in August now, the same fire danger day. So that means the season has extended longer. So that makes situation worse. So the biggest change, I think, on climate change, our Australian climate is on our rainfall, especially the cool season rainfall in the southern half of Australia. I'm emphasizing on that because we know that cool season rainfall for the southern part of Australia is very important for agriculture. And if you see that the map on the left is showing how different, how significantly the rainfall has decreased over time. There are some increase in the north too for wet season rainfall, but that's probably less significant than the decrease in cool season rainfall. So this is another thing I will quickly go through. Sea level rise. So the change in sea level, I mean, the plot on the right is showing the increase in sea level. This is the global situation, and Australia is nowhere behind there. The bottom plot on the map is showing the sea level rise for Australian location across the coast. So with sea level rise is projected to be like 0.2 to 1 meter by the end of this century along the east coast of New South Wales. And 1 meter sea level rise means like almost 75,000 properties and many kilometers of roads and other infrastructure will be inundated during major storm, like low-lying areas in estuary or vineyards or agricultural land will be impacted too. So Australia is projected to be the most adversely impacted region from climate change in terms of agriculture production and export. And the risk from that is like first order to our economy. So like crop yield, like farm productivity, and especially for, there is a high risk for Australia's wine growing region, and that will reduce and the farm productivity as well. Because of the climate window and because of the plant pathogen and pest, and they have shown lateral distributional shift, and that is going to impact our agriculture. So this is another plot like how the drought can affect the farm productivity for Australia. Just quickly skipping that. But the bottom line is we cannot completely stop climate change. Of course, emission reduction pathways are there, but we have to accommodate climate change in our planning. And this is the right time. There is no late for that. So adaptation planning has 3 stages: strategic, tactical, and operational. And long range forecast and climate projection can help for better planning and adaptation, and also for projection scenarios. So here are some products from extended prediction, which you can use. And I think Jamison will talk about this a bit more. I think with that, I will stop. Thank you.
Thank you, Jamison. Okay, our next speaker is Jamison Lowe from Melbourne. Jamison works in the agricultural sector of the Bureau of Meteorology, and Jamison's recently graduated in science, in agricultural science, majoring in plant and soil science from the Melbourne University. Jamison is from a 5th generational broadacre and cropping family property, which is north of Melbourne in Albury-Wodonga. Jamison is also currently acting in the horticultural lead role, supporting Australia's horticulture industry, sugar and wine segments. So if you could share your screen there, I can see that. That's over to you, Jamison.
Perfect. Thanks, Matt. Yeah, so hello everyone, I'm Jamison Lowe. I'm here today to share a little bit about the agriculture team at the Bureau and some of the products and services that we regularly use as part of the team. So as a part of the agriculture team, we're representatives of the ag sector, and we aim to build and maintain trusted relationships across all agriculture sectors, looking into sensitivities and production. And we ensure that any product that we roll out to the agriculture industry meets their climate and weather sensitivities. We are across 4 sectors broadly. We have customer leads in each of these specific areas. So we have a livestock specialist, a broadacre specialist, a horticulture specialist, which is inclusive of wine and sugarcane. And we also have a fisheries, forestry and emerging industries representative. One of the major projects we are focusing on currently is our project on agri-climate outlooks, which is looking at our seasonal risks and opportunities at farm commodity scale. We are using the Bush Telegraph, which we use at the agronomy or RDC scale downwards. So an example is through GRDC, through their agronomists, and then reaching the individual farmers. This project is in partnership with Agriculture Innovation Australia and representative RDCs. We also have been involved with OBSCheck. It is currently on hold at the moment, but it is utilising automatic weather stations. And we are also involved in NACP3, also known as the Northern Australian Climate Program, and that is in partnership with UniSQ and in partnership with the Climates training as well. At the moment, we are working with agriculture decision support services. So we have a people-to-people approach. We have a meteorology team with extensive experience, and they are focusing on agriculture sensitivities and aiming for those key critical farm making decisions such as harvesting or sowing. We are tailoring it to a regional and commodity specific needs. So a way you can see this work being done is we actually have a playlist on YouTube. So I will bring that up currently. Here, if you go onto YouTube Bureau of Meteorology, we've got the agriculture sector. So these are all our briefings that we've delivered. We deliver it to specific states and regions. We focus it on that and then specific commodities. So here you've got grains, rice, sugarcane here as well. So you can go through and find the commodity and area specific to yourself, with the most recent being at the top. Another one I'm going to go through is My Climate View. So I'll bring that one up. It is looking at the longer term risks and opportunities at a farm and commodity scale. It's also in partnership with the Future Drought Fund and CSIRO. So if you simply Google My Climate View, this is the website that will show up. So it's getting tailored climate information. You can put in a location or a postcode. So for this example, I've used Canberra. And the commodity I've chosen is wine grape. Depending on the location you put in, different commodities will show up. So for this example, I'm going to use wine grape. And there's a bunch of selected climate factors that you can go through. So you can go through all these different climate factors. So for this example, I'll use annual rainfall. And it tells you the definition that you're testing here. So they've said between the 1st of January and the 31st of December. You can actually modify this as well. So all of these, if you feel like a variable is more specific to you, or if you want to change the degrees threshold, you can do that just through the modify button here. You've got your past and future from 1963 to 2085, or you can go past only. We've got 2 emissions scenarios here, and for more information on that, you can just click on the information button. And then it gives you a range of scenarios in the future up to 2085 and a graph down here as well. So that's available for all different commodities and all different locations, and there is many climate factors. That's one of the major projects that the agriculture team has been focused on. Another service that we use quite a lot is the current warnings. So that's available just on the Bureau homepage. So I'll bring that one up as well for you. So if you just go to the Bureau homepage, which is bom.gov.au, here you have the warnings current, and for any state you can see exactly what warnings we have issued out. Or here you can go to heatwave tropical cyclone, tsunami, or marine. We also do have frost that comes up here. Unfortunately, I can't show you frost at the moment because we actually don't have any frost forecast warnings issued today, but you can click on any state and you can see what warnings we have present at this time. And also to see heat wave, as Janitin showed a bit on her screen. Here you can see the heat wave warnings we have for each state. So you can see New South Wales currently has none at the moment, but if you go to Western Australia, you can see the heat wave conditions that we have as well. So that's a service we use quite a bit in agriculture. Another service we use quite a lot is MetEye. So this is a service available on the same web page by BOM, and it is 3 hourly blocks of the upcoming 7 days, inclusive of rainfall, wind, waves, temperature, humidity, UV, storms. It is based on gridded data. You can type in any location or town. So if you just go to the home page, it is MetEye. It's just this one here. And for here, you can see all the variables we have here. You can type in your location at the top or your postcode. It gives you the forecast for the upcoming week here. And you can also break it down to blocks. So you can see on this one, I have pressed wind, wind speed and direction. The legend is here and it's color coded as well. And then you can go across in 3 hourly blocks and it will refresh as needed. You can do this for, we have the rainfall forecast here as well. So the 3 hourly 50% chance of more than millimeters, and that corresponds here with the legend as well. A good one to note is frost here. So under storm, snow, fog, frost, any frost, you just click here. And whilst we can't see it today because there's no frost issued, it will show up purple for heavy frost and pink for frost and remain clear as is for no frost. Another good one to know is thunderstorms. And if you zoom out, you can see that with thunderstorms, any areas, which we have quite a few today experiencing thunderstorms, it will show up in a green for chance of and red for a likely. So you can go through any of these variables here for humidity, waves, rainfall, wind, etc. And that gives you a pretty detailed forecast within 3 hours for 7 days. And the last product I'm going to go through is Climate Outlooks. So this is great because it goes out for the coming 3 months and gives you the chance of extremes such as unusually cool or unusually warm. So I'll bring that one up for you. So you can just type into Google Climate Outlooks and this is exactly what will come up. So here we've got rainfall and temperature as our 2 climate outlooks. So you can do chance of above medium, chance of extreme. So if you want to see if it's going to be unusually cool, so you can do minimum temperature, chance of extremes, unusually cool or unusually warm. Similar thing, the search button is just above here. So you can type in a location or you can press find me as well. It does take a little bit to load, but up the top here you've got 1 week, 2 week, 1 month, 3 month, and you can also use this sidebar as well to just see the upcoming month as well. So when you zoom in, you can see the chance I've got here, the chance of unusually cool. And these are the deciles as well. So when we run the model, I think it's a 99 or 100 times, we can see exactly how many times the model ran for each decile. So 62% of the time it ran in the deciles 9 and 10. As comparison, in deciles 1 and 2, it only ran 3% of the time. So you can also see unusually warm, and it corresponds here with the legend as well. Another great feature on climate outlooks is our past accuracy maps. So when we forecast unusually cool, you can see for December when we forecast unusually cool, this is exactly the past accuracy that we've had as well. So you can see for our past accuracy for unusually cool when we forecast it, I'd say it's around that 65 to 75% past accuracy as well. So that is climate outlooks. And yes, that's all the tools that we use primarily in agriculture. Thank you.
Thanks, Jamison. That was good. There's some tools there that I hadn't seen before, actually. That's quite helpful. We've got a Q&A session now for either Janison or Jamison. So just a reminder, if anyone has a question, feel free to type it into the Q&A icon down the bottom of your toolbar and press enter and it'll send through. We've had one question come through. This might be for you, Jamison. Does YouTube, my Google View and the BOM site show the same information, or is it different information?
Thanks for the question. That's interesting and good question, I would say, because we got that question a lot of time. What's the difference? Because Bureau relies on their own model, which is access model for climate forecast, and there are other models for weather forecast. But the YouTube or Google or whatever weather and climate site we see, they may use Bureau's information along with other information. So it could be different, and at some point or sometimes you see the similarity, and another time probably not.
Okay. Hasn't been any other questions come through at the moment. That's, if any, just wait. Okay, so another one's just come through. Is it possible to show expected evaporation levels?
Yeah, it's possible. So if you evaporation level, because evaporation is not always an observed parameter. We have some observation, but based on that, it's mostly modeled. So there is a website which is Australian Water Outlook, and you can go to that website and look at, like, from where I showed the soil moisture. So you can go and check the evaporation and forecast for the time for next 3 months or so.
Okay, Jamison, was that Australian water level outlook?
Water Outlook.
Water
Just
Outlook.
Australian Water Outlook, yeah.
Okay. There has been another question come through. Quite a lot of the data began in 1910. Question mark, why?
I think we have like various data set like stream flow, rainfall, temperature. Some of the temperature data set goes like beyond this last century, like in 1850 or so, but not consistent. The reason we always mention 1910, especially when you will see that when we show the gridded data set. So that's the time since when the reliable and consistent and enough sparse data covered the country, so that we can use those station data, because we all know that the observation, primary observation, is always a station observation. So you have to have that consistency and density of a station to come up with a consistent gridded data set, and that goes like 1910. Beyond that, there are data, but that's not consistent and not enough to produce a grid. That's why most of our gridded data set goes 1910.
Okay. Just wait a couple of seconds. There hasn't been any more questions come through. Oh, we do have another one. Question reads, can we have a bit more detail on the spray drift slide? I would be keen to know more about how we could use this information in our extension activities with farmers.
I think, is it probably for Jamison?
Yeah.
I'm trying to think of the spray drift slide.
think there was a slide and it had some purple colours overlaying the map of Australia.
Yes, I've seen it. Yes, I think we're in our decision support YouTube videos that I showed the channel. There's a few times where we do a bit of spray drift as well. So if you watch a bit of those videos, we might cover spray drift a few, especially when it's relevant or when there's high winds. Yeah.
Okay, so just to direct you to just that YouTube channel is the Bureau of Meteorology YouTube, is that right?
It's under the Bureau of Meteorology, and it'll see playlists. And if you press on agriculture, there's all our videos there from our agriculture decision support team.
Okay, there's been a couple more come through. How long do you predict a forecast dry period will last?
Yeah, for that question, I will just quickly share my screen of this slide again. So as we know that this dry condition is mostly driven by El Nino Southern Oscillation, and so El Nino phase, and also a bit from IOD. As you can see from the graph, like we are expecting to see this El Nino condition continue till March, April. But I think I probably mentioned that the most significant time for this El Nino is spring and to summer, and for IOD it is winter and spring. So ideally, spring is the month when spring is the season when we see the combined effect most significantly, and we kind of passed that period. And you have seen like last 3 months rainfall had been really low, so we can say that we have seen the peak of that dry period. But given that summer is already like hot and warm condition, and if a bit of less rainfall, and we have seen like past couple of months low rainfall, so we will see combined impact in coming months. But probably after summer, autumn, things will change, because autumn is the time when these systems actually break down and turns into something new, or just replenish itself. So we will be seeing this dry condition throughout the summer.
Okay, there's been another question come through that's quite relevant for the grape and wine industry, and it's relating to frost. And the question reads, how far in advance can you forecast frost accurately? Question mark. How many days ahead? Question mark. Can a freak frost occur without warning?
I think frost forecast is at a time for 3 days, and it goes up to 7 days. So frost forecast from today is like for next 3 days, and if I click tomorrow, it will be for next 3 days. So up to this like 7 days, you will see that from MET-I, everything at weather scale, as I said, 0 to 7 day. So those forecasts. So for accuracy, I think definitely first 3 days will be good. As closer to the time, it's more accurate. As when we see the rain or frost or the weather situation in the horizon in radar, we are really sure. Otherwise, things can really shift. But it's best way to keep an eye on those kind of things like thunderstorm. We cannot just predict it really long. It has to be like on time. So accuracy, I presume, I'm not totally sure about the method that they forecast, but accuracy should be low when it is for longer time.
Okay. There has been another question to do with long-range outlooks. So for long-range outlooks, elders use one of the available models. Which model is best for rainfall outlooks on a 7 to 10 day outlook? The Bureau of Meteorology or elders or other?
It's a very difficult question to say. It's like Bureau of Meteorology is yeah, there are different models. Like we use other climate models guidance, especially for our drivers forecast. But ideally, we follow for long range forecast, we follow XSS 2 model. There is no direct answer to that. It could be different for different time. I think one good analogy to that is like you probably go to a good doctor anticipating that you'll get a good prescription, but it's not always true. So every model has their shortfalls and strength. but definitely access model is calibrated for Australia. It is expected to give better result than any other models.
Okay, I think that's, just wait a second. No, I think that's all the questions. Look, just like to thank both of you, Dr. Janison and also Jamison, for joining today, providing insights into the weather outlooks and projects in agriculture. I'm sure everyone who's attended today got a lot out of this session. I'd also like to thank you, the audience, for logging in and taking the part, and would like to remind you that always you will receive a link to view the recording of this presentation, which will be available on the Adbri's YouTube channel. We will be back again next week with another Adbri webinar. That'll be on Thursday, the 30th of November, titled Subsurface Irrigation to Reduce Weed Management Costs and Chemical Use and to Improve Irrigation Efficiency. So if you'd like to register for this session, please visit the Adbri website. Thank you again, and I look forward to seeing you all at the next Adbri webinar.
Thank you.
Thank you. Have a good day.